All right, this is going to be an example of a combination of two proportions, but we're looking at a confidence interval. All right, so let's say I didn't know that this was proportions. What are the hints? So it's talking about a survey. We've got a random sample of 799 teens and a number of adults, 2,253 adults. And in these two studies, 80% of teens and 69% of adults use social networking sites. So we can see that this is a proportion. 80%, percents and proportions are the same thing. So we have p hat 1, this is the teens percentage, and p hat 2 is the adult percentages. And these are statistics. These are based on samples. So we're going to compare these two to make assumptions about the entire population of U.S. adults and the entire population of U.S. teens. So in this example, they first have the people calculate the standard error. We're not going to do that. We're going to jump right into constructing the 95% confidence interval. So if you remember that with confidence intervals, we want to use panic, right? So step 1 is they're stating P. So P is, you talk about the parameter. Again, that's a thing about the entire populations that you care about. So we care about the proportion of all U.S. teens and the proportion of all U.S. adults that use social networking sites, and we're going to compare these two together. Okay, so we're looking for that estimated difference of the entire population. Notice there's no hats on these because that's what I care about, is the entire populations. All right, so that's the P of panic. So if we go to the next page here, now we're doing the assumptions. So we have to check for randomness. So we first state that, yes, they were stated that they were independent random samples, so check on random. We have to do the 10% condition. So we have to take the sample sizes times 10 and presume or assume that the populations that we care about are larger than that. So 799 was the sample size, of the teens, times 10. Well, there's definitely more than this many teens in the U.S. And then we did the same thing with the adults, times 10. There's definitely more than that many adults in the U.S. So we're good on the 10% condition. And next, so that tests kind of independentness. And then lastly, we have to check normalness. Okay, so that's the LCC. I see students oftentimes incorrectly use the CLT here. CLT is for samples, where you're looking at the mean, not proportions. So proportions, we always use the LCC. So it's a little harder here than in previous chapters because we have two samples to look at. So we have to look at both samples individually and check that the LCC is true. We have to make sure all four numbers are larger than 10. So 799 times 0.8 and also 799 times 0.2. Those are both larger than 10, so that's good. And then the adults times 0.69 and the adults times 1 minus 0.69 is also larger than 10. So good. We check all of our assumptions. Check, check, and check. Okay. Now the N of panic is to say what you're going to use. Well, we have proportions. We are comparing two things, and so we're going to do, and it's a confidence interval, so we're going to use a two proportion Z confidence interval. Okay. So now is when we actually find our interval. So you subtract the two proportions, and it doesn't matter that we have different sample sizes because proportions kind of negate the sample size. So we take 0.8 minus 0.69, so then we get 0.11. So that's going to be the center of our confidence interval. Z star, we talked about that in the previous video. How do you find Z star? Well, it's a 95% confidence interval. So I go grab my calculator. 100%. So 100% minus 95 is 5%. So the two tails have to add up to 5%. So one tail, if I divide that by 2, is 2.5%. So I'm going to do inverse norm, 0.02501, enter, 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 boom. So that's my Z star. So notice they put 1.96 there. That's Z star. Then I have to find the standard error, which we're using kind of as an estimate for standard deviation because we don't know the actual populations, proportions, so we're going to have to base it upon our samples, so p hat. So notice that we do 0.8 times 0.2 divided by the sample size of the teens, 0.69 times 0.31 divided by the sample size of the adults. Put this all together, and that is our standard error. Multiply these two together, and this all together is our margin of error. So this here, this part, is the margin of error. So we're going to add that and subtract it from 0.11, so then we get this confidence interval. So because of this confidence interval, we can conclude that we are 95% confident that the actual difference of the proportion of US teens and adults that use social networking is somewhere in this interval. All right, 95% confident. It's not a guarantee, but we're 95% confident it's going to be in there. So that's an example of a two-proportion confidence interval.